All right, number 31. Okay. The question states in the following problems, find A and B such that the statement is true. Okay. So if we look at the statement in 31, we have 8 to the A power. All right. I have poor penmanship. It looks like a 9. That's an A. Plus 27I equals 2 plus 9 to the B power times I. All right. So both of these numbers are complex numbers in standard form. All right. AA and 2 are the real parts. 27I and 9BI are the imaginary parts. So what we're going to do is we're going to set them equal. All right, I'm going to set 8 to the A power equal to 2. So I figure out what value of A would make that 2. Then if I figure out what value of B would make 27I equal to 9 to the B power times I, then I have my solution. So we got to solve these two equations here. All right, for B, for 8 to the A power, we haven't learned log functions yet, but hopefully you could figure out what power you would raise 8 to get 2. Now, 8 is bigger than 2, so to make it smaller, we have to take a root. The square root of 8 isn't a perfect square, so it's not 2. So 8 isn't a perfect square, So the square root of 8 isn't 2. But if you try the cube root, it works. All right, so we get A to the 1/3 power is equal to 2. All right? Now with B, we could cross out I on both sides. We could divide by I. Then we have to figure out 9 to the what power equals 27. So if you square B, if you square 9, you get 81, which would be too big, which means B has to be less than 2. But if you raise 9 to the first power, you get 9, which is too small, which means B has to be in between 1 and 2. So what we're going to do is we're going to take 9 and we're going to take the square root and get 3. Then if you cube it, you get 27. So there's our exponent that we need for B. B should be 3/2. And A is 1/3. So this is like a system of equations, but you have to figure out what exponents A and B have to be to make the statement true. And that's all we got for today. Tune in next week for more